Our solar system is a stage for a grand cosmic ballet with the Sun as the central star. Planets twirl around the Sun, each with its own unique rhythm and grace. Among these celestial dancers is Jupiter, a gas giant of immense proportions. Jupiter commands attention with its swirling storms and a retinue of over 80 moons. These moons, like a loyal audience, orbit the massive planet, each with its story to tell. One such moon, shrouded in mystery and intrigue, is Elara. This small, distant world holds clues to the formation and evolution of Jupiter's intricate system of moons. Join us as we embark on a journey to explore Elara, a small moon with a big story to tell. The year 1905 marked a pivotal moment in our understanding of the cosmos. American astronomer Charles Dillon Perrine, working at the Lick Observatory, made a groundbreaking discovery. Through the lens of the observatory's powerful telescope, Perrine spotted a faint object moving near Jupiter. This object, a previously unknown moon, would later be named Elara. Perrine's discovery expanded our understanding of Jupiter's system. It hinted at the possibility of even more hidden worlds orbiting the gas giant. As we delved deeper into the study of Elara, we began to uncover more secrets hidden within its faint glow. Elara, named after a lover of Zeus in Greek mythology, is more than just a tiny dot in space. It is a celestial enigma, holding within its icy surface clues to the early solar system. Its small size and irregular shape hint at a turbulent past. Scientists believe that Elara may hold valuable information about the formation of Jupiter's moons. By studying its orbit, composition, and interactions with other moons, we can gain insights into the processes that shaped our solar system. Each new discovery brings us closer to understanding our place in the cosmos. Elara has become a window into the past, offering us a glimpse into the formation and evolution of our solar system. Elara, even through the most powerful telescopes, appears as a faint point of light. Scientists estimate Elara's diameter to be approximately 80 kilometers. Despite its diminutive size, Elara holds a fascination for astronomers. Its small size tells us that it is likely an irregularly shaped object. It lacks the gravitational pull to mold itself into a sphere like larger celestial bodies. Observing Elara from Earth is a challenging task. Its faintness requires powerful telescopes and sensitive instruments. Each observation helps us refine our understanding of Elara's physical properties and its place in Jupiter's dynamic system. While we have yet to send a spacecraft to Elara, scientists have gleaned some information about its surface. Based on observations, it is believed that Elara is covered in water ice. This icy surface is likely ancient, dating back to the early days of the solar system. Like most airless bodies in the outer solar system, Elara's surface is probably heavily cratered. Each crater tells a story of a collision with an asteroid or comet, some impacts dating back billions of years. Studying the composition of Elara's surface can provide valuable clues about the conditions and materials present during the formation of Jupiter and its moons. One of the intriguing aspects of Elara is its color. While it appears gray to the naked eye, more detailed observations reveal subtle reddish hues. This reddish tint suggests the presence of organic molecules on its surface. These molecules could have been delivered to Elara through impacts from comets or asteroids. Understanding their distribution and abundance in the outer solar system could provide valuable insights into the conditions that led to the emergence of life on Earth. Elara's rotation period is another intriguing aspect of this distant moon. Observations suggest that Elara takes approximately 26 hours to complete one rotation. This slow rotation is likely influenced by Jupiter's powerful gravitational pull. The slow rotation of Elara has implications for its surface temperature. with extreme differences between its day and night sides. Further study of Elara's rotation could provide insights into its internal structure and the distribution of mass within this small, icy world. Elara orbits Jupiter at a distance of approximately 11.7 million kilometers. From Elara's surface, Jupiter would appear as a dominant presence in the sky. Unlike the nearly circular orbits of Jupiter's inner moons, Elara's path around the gas giant is highly elliptical. This means that Elara's distance from Jupiter varies significantly throughout its orbit. At its closest approach, Elara ventures closer to Jupiter, experiencing a stronger gravitational pull. As it swings further away, Jupiter's grip weakens and Elara's speed slows. Their irregular orbits and diverse compositions suggest a history independent of Jupiter's formation. Elara's orbit exhibits a fascinating phenomenon known as orbital resonance. In Elara's case, it is locked in a 3-to-2 resonance with the moon Himalia. This resonance means that for every 3 orbits Elara makes around Jupiter, Himalia completes 2. This gravitational dance ensures that Elara and Himalia never collide, despite their intersecting orbital paths. The presence of this resonance suggests that these moons have been interacting gravitationally for a very long time. Elara is a member of a group of moons known as the Himalia group. This group shares similar orbital characteristics, including their distance from Jupiter and their elliptical orbits. The moons of the Himalia group are thought to be remnants of a larger parent body that was captured and subsequently shattered by Jupiter's gravity. Studying the Himalia group provides insights into the dynamics of early planetary systems. Their capture and subsequent evolution offer a glimpse into the chaotic processes that shape the solar system we see today. While we observe Elara's orbit as it is today, it is important to remember that orbits are not static. Over vast cosmic timescales, even the orbits of moons can change due to gravitational interactions with other celestial bodies. Scientists believe that Elara's orbit has evolved over billions of years. By studying Elara's current orbit and comparing it to models of the early solar system, astronomers can trace back its orbital journey through time. Understanding the evolution of Elara's orbit provides valuable information about the history of Jupiter's moon system. Elara, though a small and distant moon, holds clues to the formation of the Jovian system. Scientists believe that Jupiter, in its infancy, was surrounded by a swirling disk of gas and dust. This disk, called a circumplanetary disk, is where Jupiter's moons are thought to have formed. The inner moons, like Io and Europa, likely formed from the denser, warmer material closer to Jupiter. Elara and its siblings in the outer system, however, tell a different story. Their irregular orbits and diverse compositions suggest they did not form in this inner disk. By studying the composition and orbital characteristics of Elara and other irregular moons, scientists can learn about the conditions in the early solar system. Elara, like all of Jupiter's moons, experiences the immense gravitational force of the gas giant. This force, known as a tidal force, is responsible for some of the most dramatic phenomena in the solar system. While Elara itself is too small and rigid for tidal forces to have dramatic surface effects, scientists can study its orbit to measure the strength and variation of Jupiter's gravitational field. These measurements help refine our understanding of Jupiter's internal structure and the distribution of mass within the gas giant. Elara acts as a sensitive probe, allowing us to indirectly study the hidden depths of Jupiter. The early solar system was a chaotic place, with planets migrating and leftover debris bombarding the surfaces of young planets and moons. One significant event in this early period is known as the Late Heavy Bombardment. a period of intense asteroid and comet impacts that occurred roughly 4 billion years ago. While Elara's exact crater density is unknown, its ancient surface likely bears the scars of this tumultuous period. Studying the crater record on Elara could provide insights into the intensity and duration of the late heavy bombardment in the outer solar system. This information would be invaluable for understanding the impact history of the early solar system and its effect on the evolution of life on Earth. Section 4. Sentinels of the Outer System. Elara's role in planetary defense. In the vastness of space, objects like asteroids and comets pose a potential threat to planets like Earth. While large impacts are rare, they can have catastrophic consequences. Understanding the population and orbits of these near-Earth objects, or NEOs, is crucial for planetary defense. Elara and other outer solar system objects can play a surprising role in this effort. Their orbits, influenced by the gravity of Jupiter and other giant planets, can act as sensitive detectors for the presence of larger, unseen objects. By carefully monitoring the orbits of these distant sentinels, astronomers can detect subtle gravitational perturbations that might indicate the presence of a previously unknown NEO, even one that poses a potential threat to Earth. Elara and its siblings, in this way, contribute to our understanding of the solar system's dynamics and our ability to protect our planet from cosmic hazards. Section 1. Uncharted Territory. The Quest for Close-Up Views. Despite decades of observations from Earth-based and Earth-orbiting telescopes, Elara remains largely unexplored. Its small size and distance from Earth make it a challenging target for detailed study. However, advancements in telescope technology and the development of more ambitious space missions offer hope for a closer look at this enigmatic moon in the future. One possibility is the development of even larger, more powerful ground-based telescopes. These next-generation observatories, equipped with advanced adaptive optics to compensate for the blurring effects of Earth's atmosphere, could provide images of Elara with unprecedented resolution, potentially revealing surface features and details about its composition. Another exciting prospect is a dedicated mission to Jupiter's outer moons, including Elara. Such a mission could involve a spacecraft carrying a suite of instruments designed to study the moon's composition, geology, and magnetic environments. A lander, similar to the Huygens probe that landed on Saturn's moon Titan, could provide the ultimate close-up view of Elara's surface, analyzing its ice and searching for signs of organic molecules. Section 2. A Glimmer in the Dark. Elara's Faint Ring. One of the most intriguing and unexpected discoveries related to Elara is the presence of a faint ring of dust particles orbiting Jupiter in the same region as the Moon. This ring, discovered in 2000 by the Galileo spacecraft, is extremely tenuous and difficult to observe directly. Scientists believe it is formed by dust particles ejected from Elara's surface due to micrometeoroid impacts. The existence of this ring, though faint, provides further evidence of Elara's connection to the dynamics of the Jovian system. The constant bombardment of micrometeoroids, small particles of interplanetary dust, chips away at Elara's surface, releasing dust particles that become trapped in Jupiter's gravitational grip. Studying the properties of this ring, such as its density, composition, and the size distribution of its dust particles, can provide insights into the processes that shape the surfaces of small, airless bodies in the outer solar system. It also highlights the interconnectedness of objects within a planetary system, even those separated by vast distances. Section 3. Echoes of the Past. Unveiling Elara's Interior. While we can observe Elara's surface and orbit directly, its interior remains hidden from view. However, scientists can use a combination of observations and computer models to infer some details about Elara's internal structure. Based on its size and estimated density, It is believed that Elara is composed primarily of water ice, with a smaller proportion of rock and metal. The internal structure of Elara is likely differentiated, meaning that it has layers of different compositions. The denser rock and metal would have sunk towards the center early in its history, forming a core. This core is likely surrounded by a mantle of water ice, which may exist in different phases: solid ice, liquid water, or a slushy mix, depending on the temperature and pressure conditions within Elara. Future missions to Elara, equipped with instruments to measure its gravity field and magnetic environment, could provide more definitive information about its internal structure. Detecting variations in Elara's gravity field as it orbits Jupiter could reveal clues about the distribution of mass within the Moon, while the presence or absence of a magnetic field could indicate the presence of a liquid layer, such as a subsurface ocean, within its icy mantle. Section 4. Future Frontiers, Elara in the Age of Exploration. As we venture further into the age of space exploration, Elara and other small, distant worlds in our solar system represent exciting targets for future missions. These celestial bodies, once mere points of light in the night sky, are now recognized as potential treasure troves of scientific information, holding clues to the formation of planetary systems, the distribution of organic molecules, and the history of our cosmic neighborhood. The continued development of powerful telescopes, both on Earth and in space, will undoubtedly reveal more secrets about Elara in the coming years, refining our understanding of its surface features, composition, and the dynamics of its faint ring system. However, to truly unlock the mysteries held within this small, icy world, a dedicated mission to Jupiter's outer moons, equipped with the tools to study Elara up close and personal, is the ultimate goal. Perhaps one day in the not-too-distant future, humans will set foot on Elara's surface, collecting samples of its ancient ice, searching for signs of past or present geological activity, and gazing up at the majestic sight of Jupiter dominating the alien sky. Such a mission, driven by our insatiable curiosity and thirst for knowledge, would mark a significant milestone in our exploration of the cosmos and our quest to understand our place within it. Section 1. Elara's Enduring Allure, a small moon with big secrets. Elara, a small moon orbiting Jupiter, holds secrets that could reshape our understanding of the cosmos. Its discovery opened our eyes to Jupiter's complex moon system. Elara's surface, scarred by impacts, whispers tales of the early solar system. Subtle reddish hues hint at organic molecules, raising questions about life beyond Earth. Section 2. Reflections on a Distant World, Elara's Place in the Cosmic Order. In the grand tapestry of the cosmos, Elara may seem like an insignificant speck, a tiny world orbiting a giant planet in a seemingly ordinary galaxy among billions. Yet, its very existence speaks to the interconnectedness of all things in the universe. The same forces that govern the motion of planets and stars also shape the orbits of moons like Elara, a testament to the universality of physical laws. Elara's capture by Jupiter's gravity billions of years ago was not a random event, but rather a consequence of the intricate dance of gravity and the distribution of matter in the early solar system. Its presence, along with the other moons in the Himalia group, provides valuable clues about the conditions that prevailed during this early era, helping us to piece together the story of our cosmic origins. Furthermore, Elara's role as a sensitive probe of Jupiter's gravitational field and its potential as a sentinel for detecting hazardous near-Earth objects highlight the practical implications of studying even the most distant and seemingly insignificant celestial bodies. In a very real sense, what we learn from Elara can help us to better understand our own planet and safeguard our future. Section 3. A Universe of Wonder, Elara and the Future of Discovery. As we stand on the cusp of a new era of space exploration, the future of Elara research is filled with promise. Imagine the thrill of receiving the first high-resolution images of Elara's surface, revealing its cratered landscape in unprecedented detail. Elara has the potential to ignite our imaginations and inspire generations to come.